How snakes move. Introduction. Snakes are some of the most fascinating creatures on Earth, capable of moving in ways that seem almost magical. Unlike most animals, they don't have limbs, yet they can slither, climb, swim, and even glide through the air. This article explores the different types of snake locomotion, the science behind their movements, and real-life examples that illustrate their adaptability. By the end, you'll gain a newfound appreciation for these remarkable reptiles. The power of snake muscles. One of the most impressive aspects of snake movement is their musculature. Snakes have between 10,000 and 15,000 muscles, allowing them to move with astonishing precision. Their striking motion, for example, is one of the fastest movements in the animal kingdom. Some snakes can launch their heads forward in less than 70 milliseconds, faster than the blink of an eye. Even non-venomous snakes like rat snakes can strike with acceleration so intense that it would cause a human to black out. Example, the kangaroo rat and the rattlesnake. Nature has endowed certain animals with reflexes swift enough to counter snake strikes. One such example is the kangaroo rat, which can leap away from a rattlesnake strike in an instant. Because a rattlesnake strike is a committed motion with no ability to change direction mid-air, a perfectly timed dodge can be the difference between life and death for the rat. Different types of snake locomotion. Despite not having legs, snakes have developed several unique methods of locomotion, each adapted to different environments. Let's break them down. 1. Rectilinear locomotion, linear movement in a straight line. This method represents the most fundamental form of snake movement and is commonly observed in large, heavy-bodied snakes like boas and pythons. Rather than slithering, the snake progresses in a straight line by alternately extending and contracting its muscles. While it may appear simple, it is remarkably effective for stealthy movement, especially when a snake is stalking its prey. Example, Burmese pythons in the Everglades. Burmese pythons, an invasive species in Florida, employ rectilinear locomotion to stealthily approach their prey. By moving without noticeable undulations, they can get close to unsuspecting animals without attracting attention. 2. Lateral undulates traditional slithering. This is the most widely recognized type of snake movement. The snake moves by forming a series of S-shaped curves, utilizing friction against surfaces such as rocks, branches, and grass to push itself forward. Example, water snakes hunt fish. Water snakes employ lateral undulation to move through aquatic environments. By creating wave-like motions with their bodies, they produce propulsion in a manner similar to how eels swim. 3. Sidewinding, the desert adaptation. In sandy environments, sidewinding is the favored method of movement. By lifting portions of their bodies off the ground, snakes lessen contact with the hot sand and decrease energy expenditure. Example, sidewinder rattlesnakes in the desert. Sidewinder rattlesnakes employ this technique to navigate loose desert sand. Their unique J-shaped tracks serve as evidence of the effectiveness of this movement. 4. Concertina locomotion, climbing and navigating tight spaces. When moving through narrow passageways or climbing trees, snakes employ a stop-and-go technique known as concertina locomotion. They secure part of their body while extending the rest forward, then draw the rear section up to repeat the process. Example, tree-dwelling boas in the Amazon. Amazon tree boas employ concertina movement to ascend trees and capture birds. Their strong muscles and specialized belly scales enable them to grasp branches firmly. 5. Lasso locomotion. Some snakes have developed a distinctive method to ascend vertical, smooth surfaces by forming their tails into a lasso shape and shimmying upwards. Example, brown tree snakes attacking bird nests. Brown tree snakes, an invasive species in Guam, have perfected lasso locomotion to scale poles and raid bird nests, posing a threat to native bird populations. Snakes that glide through the air. While it might sound like science fiction, some snakes can glide through the air. Flying snakes, found in Southeast Asia, flatten their bodies and use lateral undulation midair to control their descent. Paradise tree snakes in Thailand. These snakes launch themselves from trees and glide distances of up to 100 feet, allowing them to escape predators and hunt prey in different locations. Lessons from snake movement. The study of snake locomotion has inspired technological advancements in robotics, biomechanics, and even prosthetic design. Engineers have created snake-like robots that can navigate disaster zones, helping in search and rescue missions. Example, snake-inspired robots in disaster relief. Roboticists have developed flexible robots based on snake movement, capable of squeezing through rubble to locate survivors after earthquakes. Conclusion. Snakes are extraordinary creatures with an unparalleled ability to move efficiently in various environments. Their unique adaptations provide valuable insights into biology, physics, and even engineering. By understanding and appreciating these reptiles, we can also contribute to their conservation, ensuring their continued role in the ecosystem.